Here is the Bernoulli substitution method. So look at the equation here given in this form. The first order differential equation du dx is the derivative term, and then you have the linear term which is p times y, and on the right hand side you have qx times y to the power n. So right hand side you have a y to the power n terms, which makes the equation non-linear. And remember, if you have n equal to 0, then the right hand side will be just a function of x. Then the entire equation will be just a linear equation, and then you can apply the linear method. So we are not considering n equal to 0. Now again, if n equal to 1, you can immediately see that the equation is separable. So we are not considering n equal to 1. For anything else other than 0 and 1, this equation has a derivative term, a linear term, and a non-linear term. The coefficient of linear term is, of course, a function of x. The coefficient of non-linear term is, of course, a function of x, and non-linear term is just y to the power n. And here is an example, and you see that the example is a little bit different. So we can rewrite the example in the standard form. And you see that the p is 2 by x, q is 5 by x square, and n is 3. N is 3. This is important. Okay. So in this case, we will use a substitution. And the idea of substitution is you take a variable u and replace it with y to the power 1 minus n. That's 1 minus n. So y is your variable to be solved. So you power this variable to 1 minus n. N is the power on the right hand side. 1 minus n. So n is 3. So y to the power 1 minus 3 is minus 2. Okay. So u is y to the minus 2. So you decide this is your substitution. Once you know the substitution, you can rewrite it. U is y to the power minus 2. You can say y square is u. Y square is u to the minus 1. And then y is u to the minus half. Then you can replace u with y to the power minus 2 or y with u to the power minus half. Once you have u to the power minus half for y, you substitute back into this differential equation which is in the standard form. And to do that, you have to calculate dy dx and then put the value of y, dy dx, and y cube. So let's first calculate dy dx, which is easy. Take dy dx. So u to the minus half u to the minus half minus 1 will be minus 3 over 2. Half minus 1 is minus 3 over 2. Now u is also a function of x, so use chain rule. Okay, so then you want to use dy dx into the original equation. Substitute that. So this is for dy dx plus 2 by x times y u to the minus half 5 by x square y cube, which is u to the minus half to the power 3, u to the minus half to the power 3. And now we can simplify it. So we are going to make the coefficient of first derivative 1, or we are going to convert this equation into normal form. So you divide by negative half e to the minus 3 over 2. So second term becomes negative. Now divide 2 by half would be 4. And you have divided by x. Now you are going to divide u to the minus half. U to the minus half by u to the minus 3 by 2. So division means now here will be a subtraction. So minus half minus 3 over 2 would be u to the power 1. On the right hand side, you are dividing by minus half. So minus 10 by x square. And you are dividing by u to the minus 3 over 2. And you have a u to the minus 3 over 2 which get cancelled. So what you see here, the nonlinear equation has been turned into a linear equation. And now here you can apply the linear method. And in order to apply the linear method, you find a integrating factor. And remember, you do not try to memorize the formula for integrating factor. Instead, you calculate it. So the integrating factor, we write an equation for d mu dx, and on the right hand side, left hand side is d mu dx, and on the right hand side is the second term of your differential equation. And often there is a sign mistake, so you don't take this term to the right hand side, you just write down what is here. What is here on the right hand side of your d mu dx, and then you replace u to mu. So this equation is separable. So you can integrate it. So if you integrate, you get ln of mu on the left hand side and negative 4 ln of x on the right hand side, which becomes ln of x to the power minus 4, and then ln get cancelled, mu equals x to the power minus 4. So this is the integrating factor mu, which is x to the power negative 4. Now once we know the integrating factor, what we do is we take this linear equation, multiply both sides by x to the power minus 4. We multiply by x to the power minus 4, 4x to the power minus 3 minus 10 x to the power minus 4. So minus 4 minus 2, which is negative 6. Now you realize that in the second term of the right hand side, you have the coefficient negative 4 x to the power negative 3. This can be written as ddx of x to the power negative 4. You see, ddx of x to the power negative 4 is negative 4 times x to the power negative 5. So this 3 should be a 5, because when I am multiplying here by x to the power negative 4, I get negative 4 over x to the power 5, or negative 4 times x to the power negative 5. So in that case, this entire left hand side can be written using the product rule, and then you can just integrate both sides. On the left hand side you have ddx of something, and on the right hand side you have a function of x. So both sides you integrate with respect to x, giving you x to the minus 4 times u on the left hand side, and on the right hand side you integrate, and that's just first year calculus. Integration x to the power minus 6 is going to be minus 10 divided by, so integral x to the power minus 6 is, I use the formula x to the power of n, so n plus 1, so 1 by n plus 1, n is negative 6, so 1 by negative 6 plus 1 is negative 5, x to the power negative 5, and put a constant, which is the constant of integration. So you can multiply now by x to the power 4, which makes things simple. So on the right hand side, first divide 10 by 5, which is 2, and you multiply by x to the power negative 4, gives you 2 times x to the power negative 1 plus c multiplied by x to the power 4. Then what you have here, u is equal to 2 times x to the power minus 1 plus c times x to the power 4. Replace u. So you see, what is u? U is y to the power negative 2, y to the power negative 2 equals 2 by x plus cx4. You can make reciprocal on both sides. Then left side will be y square, and right side you can first combine them together, 2 plus c x to the power 5, and then make reciprocal, so x divided by 2 plus c x to the power 5, and this now allows you to write down y explicitly in terms of x. Okay, and this will be the final answer. So look at back the solution process. The first thing to look at whether the equation is in the Bernoulli form. So we rewrite the equation to make it into the Bernoulli form, and then use the Bernoulli substitution. So Bernoulli substitution lands you into an equation that is linear. So in here, if you don't get a linear equation, then the chances that you made a mistake. So you can actually understand whether you are going to the right direction or not. So once you have a linear equation, you can find an integrating factor and multiply the linear equation by the integrating factor. After you have multiplied the linear equation with the integrating factor, you should get a product rule, derivative of a product on the left hand side. If you don't get that, this is here another cross check that you might have made a mistake. Well, if you get that, you still may make a mistake. You can get that incorrectly. That's other point. But if you don't get a product rule on the left hand side of your linear equation after you have multiplied by the integrating factor, chances that you made a mistake if you sit back and cross-check where is the mistake. And then the straightforward algebra, you get y equals square root of x divided by square root of 2 plus c x to the power 5. Thank you for watching.